Welcome to Unit 3, Day 2. Today we're taking up a notch what we learned about solving two-step equations. If you have any questions, you can refer to 2.3 in your book. Okay. Looking at this equation that I need to solve, which means I'm trying to figure out which value of x makes that equation true. So first question I'm going to ask myself is, are both sides simplified? And this side is not simplified. What do you think I'm going to do? I don't know. Let's go. Let's try that again. Okay, maybe not. All right, we're going to go ahead and simplify it. So we know our steps to simplifying. Let's leave, change, distribute, combine like terms. So we're just simplifying each side on its own. So our first step is to leave, change. And I end up with 5x. Remember, I'm distributing. So I'm going to multiply both x and negative 6 by 5. 5x plus negative 30 equals 15. Good, now it's simplified. Then I'm going to ask myself, is my variable term isolated? Which means, do I have anything that was added or subtracted to it? And look, I have this negative 30 here. So I've got to get rid of that. Because I just want to have my variable term 5x by itself. So let's see. And what is the opposite of subtracting 30? Or adding negative 30? It would be to add 30. So I'm going to add 30 to both sides. And the reason I'm doing that is because I really want this thing right here. I want it to equal 0. I don't want any constants. Right now I have a constant of negative 30. Okay. And so I'm going to add 30 to both sides, and I'll end up with 5x plus 0 equals 45. So now I'm just left with this variable term 5x, and remember multiplication is a pretty tight bond. We're going to leave that one for last. And so what is the inverse operation to multiply by 5? It is divide. Let's see if, oh, it does work now. Okay, so we're going to perform the inverse operation on x's coefficient, divide sides by 5, and I end up with x is equal to 9. Cool. So watch, check my work. I'll do it over here. I have 5 times 9 minus 6 equals 15. Okay. Now PEMDAS tells me to do what's in my parentheses first, and I can do that. So I end up with 5 times 3 equals 15, because 9 minus 6 is 3. 15 equals 15. Yes. So my answer equals 9. That's my solution. 9 is the number. Plug into this equation, that'll make it true. Okay, here we go. Let's ask ourselves a question. This looks complicated. Let's see what happens. Are both sides simplified? Yes, both sides are simplified. There are no operations that I need to do on either side. And I'm left with unlike terms over here. I can't combine those at all. So we are good to go. Let me see. Oh, see, that's working now. I don't have to do any of that. Okay. Is the variable term isolated? Are there no constants? So this is my variable term, right? And I'm adding a constant to it. I'm adding 1/9 to it. So it's not isolated. I've got to get rid of that 1/9. So I'm going to subtract 1/9 from both sides. Well, let me show you what this is. I'm going to subtract 1/9 from both sides. And I'm going to have to figure out what 7/9 minus 1/9 is. I'll figure that out in a second. And I'm left on my right side with just 2n. We have the same denominators, so this subtraction problem is actually quite easy. 7/9 minus 1/9 is just 6/9 equals 2n. Cool. Now I'm going to ask myself, is my variable n isolated? Okay. Now there's a coefficient. There's a 2 there. Someone took n and multiplied it by 2. So what's the inverse operation to multiplication? It's division. So now I'm going to divide 6/9 by 2. Do you remember how that works? Let me write that out for you. 6/9 divided by 2. Does this help you out? Divided by 2 over 1. When dividing fractions, don't be shy. flip the second and multiply. So I end up with 6/9 times 1/2. When I'm multiplying fractions, I just go right across. I end up with 6/18, which when I simplify, 6 goes into top and bottom, becomes 1/3. Okay, it's a lot of stuff there. So that divides out. So I get 1/3 is equal to 1/3 is equal to n. Let's check our work. Okay, so I have 7/9 equals 2 times 1/3 plus 1/9. So I have, oops, didn't mean to do that. I have 7/9 equals 2/1 times 1/3. That'll be 2/3 plus 1/9. Okay. Trying to get a common denominator, so I can make a common denominator. I can turn 2/3 into 6/9. I'm going to multiply both top and bottom by 3, and I have common denominators of 9. So 7/9 equals 6/9 plus 1/9. Is that true? Yes, that equals 7/9. And I'm good to go. So my answer is n equals 1/3. Okay. Okay, first question, are both sides simplified? Let's see if I can remember to flip all these. Ah, they're not simplified, so I'm going to multiply both b and 5 by -2. That's my distributing step. I didn't have to leave change here. So I end up with -2b plus -2 times 5 is -10 equals -6. I'm going to combine like terms. Are there any like terms on that side? No. So I'm all done. No like terms to combine. All right, so I had -b 10. I'm going to add the opposite of -10, which is the same thing as adding 10. Remember, because what I'm looking for right here is I'm looking for that big 0. Okay? So if I have -10, I'm going to add 10. And I end up with -2b equals -6 plus 10 is +4. Oh well. Okay. Now I have a b, but it's still multiplied by -2. Inverse operation to that is to divide by -2. Will that work? Oh, whatever. And I divide by -2 both sides, and I end up with b is equal to 4 divided is -2. Okay, let's check our -2 times -2 plus 5 equals -6. Okay, I can do my parentheses here. -2 plus 5 is 3. -2 times 3 equals -6. And I end up with -6 on this side. Yes! I know that my solution is b equals -2. Okay. Last one. Are both sides simplified? Let me see that side on the left there. That's not simplified. I've got a negative that I need to distribute to everything inside the parentheses. I don't remember how to do that. I know if there's a coefficient, I just distribute the coefficient. Ah, there's not a number. Excuse me. If there's a constant, I take that back. Okay, there's not a number here. It's a negative. What is that? That is a -1. Good job. So leave 10, and let's distribute that negative. So I end up with -1x plus what's +10 equals 7. It's my. Are there any constants involved? Yep, there's 10 there, so let's get rid of that 10. By 10. Negative Next question is my variable isolated? Is my x isolated all by itself? No, someone multiplied him by -1. So let's divide both sides by -1, and I end up with x is equal to -3 divided by -1, which is a negative divided by a negative is a positive. X is equal to 3. I wonder if I'm right. Okay, negative. Let's see, I'm going to plug a 3 in for x. 3 minus 10. I'm going to do my parentheses first. That gives me -7. So the negative of -7 equals 7. And the negative of a negative is a positive. That's true. If you weren't sure, you could always put a 1 here. -1 times -7 is equal to +7. That is correct. This is my solution. On my number line, it is 3. Who's the happy one? He's my solution. He wins. Haley got a 60-cent raise after working at the Snack Shack for 3 months. She now earns $8.30 per hour. What did she earn before the raise? Okay, so what am I trying to figure out here? I'm trying to figure out what she earned before the raise. What did she earn before the raise? Because what she earned, that's what's changing. So that's my variable there. So it is her salary, or what she. I'm going to call that variable S. Okay? The S is changing. What kind of change happened? Well, let's see. That salary increased, right? S is what she earned before, and that increased. Let's see. She now earns $8.30. So this is basically my is statement. It's my current state. $8.30. That's basically my equals statement. So here I know that something is going to be equal to $8.30. Okay? Okay, I know my new value. Okay, and that's my equals. So let's see, I'm going to set this up. Her original salary that she earned before, and then she got an increase of 60 cents equals $8.30. How can I figure out what she used to make? It means I want to get S by itself, so I'll subtract 60 cents from both sides, and I'll end up with S is equal to, what would that be, $7.70? Okay. So her original salary was $7.70. 70 cents. Luke finished the 5K race in 21.4 minutes. This was 1.8 minutes faster than his practice time. What was his practice time? All right, so what's changing here is how fast he runs the race, right? So well, it's the time, his running time, which is changing, and I will call that variable t. All right. What kind of change happened? Well, I know he improved, right? He improved. What does that mean to improve your running time? It means that doesn't your time decrease? That's an improvement. All right, that means improved. Okay. Do we know the original value or the new value? Do I know how fast he used to run, or how fast he most recently ran? Oh, I know the new value. That new value is 21.4 minutes. That's his new value, right? Okay. All right. So that's going to be my result. Something is going to be equal 21.4. And I'm looking for his original time. Okay. Any other clues you can read in that word problem? This was 1.8 minutes faster than his original time. Faster, 1.8, faster than, and then his original time, which we're going to call t. So let's see, do you think it will be t minus 1.8 or will it be 1.8 minus t? Remember that then? I got to know his time first. I'm going to subtract 1.8 minutes from it and give me his new time, which is 21.4. Okay, think about that for a second. How can I figure out what his original time was? T. So I will add 1.8 to both sides. I'll end up with t is equal to, that's a 2, carry the 1, 3. His original time was 23.2 minutes. His original time, 23.2 minutes. The perimeter of a regular hexagon is 72.6 minutes. No, 72.6 centimeters. Write and solve an equation to determine the length of each side of the hexagon. All right, so what are we trying to find? We're trying, let's see, the question says, write and solve an equation to determine of each side of the hexagon. Okay, so I'm trying to find the side lengths. So I will say side length, and that is my variable. I will call that guy S. I'm trying to find S. Okay. So what do we know? Know the perimeter is, so I know that my perimeter is 72.6 centimeters. I also sides are there in a hexagon. I know there are 6 sides in a hexagon. So the perimeter is going to be 6 times however much the side is, right? So 6x 72.6 centimeters. So my equation will say 6s is equals 72.6 centimeters. I want to get s by itself, and someone multiplied s by 6, so I will divide away that 6, and I'll end up with s is equal to, oh, I don't know, is equal to 12.1, and that is my side length. So 12.1 times 6, excuse me, 6 times 12.1 should give me 72.6, and that is true. Last one. Alex mailed a package to Juneau, Alaska for $2.07. The first class rate was 23 cents per ounce. Write and solve me an equation to determine the weight of the package. What am I looking for, guys? I'm looking for the weight of the package in ounces. I'm trying to find its weight. And I will call that guy W. This is my variable. My variable is W. If W changes, then it'll cost a different amount. Okay? And this is what we know. I know that the total cost was $2.07. That's going to be my equal. Something is going to equal $2.07. Okay? And the rate is 23 cents per ounce. So for every ounce, it costs me 23 cents. I'll write this equation as cost me 23 cents per ounce. So 23.23 times however many ounces I have, however much my give me $2.07. Okay, had a weight, divided by 0.23. W is equal to, I'm grabbing my calculator, let's see, on 2.07 divided by 20.23, and my answer is 9. So the question says, what is the weight of the package? 9 ounces, or you could say W is equal to 9. And so 9 times 0.23, I hope gives me $2.07. Let's see, 9 times 0.23, and it gives me $2.07. And I am done. Great job. Great thinking. Take a look at those problems again, and I will see you in class